Okay, so translations in math doesn't mean that you're translating from one language to another. It means that you are moving either in the y or in the x-axis, right? So vertical sinusoid translations means what? Let's go and recap a little bit on if you have y equals x squared, this is what you have, right? And if I took this up to a 3 here, what would happen to the original equation? You would have y equals x squared plus 3, because I went up 3 in the y-axis. Is that correct? Yes. So how does that relate to sinusoids? The original sinusoid graph looks like this. Right? This is a 1, this is a 1, minus 1, and this is a 1. The amplitude, right? And this one is at 0. But what if I raise this and I start at 3 instead of 0, and now I go up to 4 and 2. My amplitude is still 1, isn't it? If I do this. This is still 360, and this is 180. Okay. This is theta, and this is y. Okay. What happened? What's the difference between this one and that one?
This one has more amplitude.
It's the same, it's the same.
Higher.
That one
It has
is
the amplitude.
Huh?
like higher in the y.
Okay.
No, means I was.
No, it's just that they're not getting it, and it's my drawing, it's my fault.
Big try.
Somebody's gonna make a meme about that, I'm sure. Okay.
Jonah.
So what's the difference? Now, I made it on the same thing.
It's higher.
It's higher, but it's exactly the same. So what changed?
You're doing that thing.
The position of the y-axis.
The one where I started out at doesn't it? So this is now a 2, this is a 1, and this is the 0. So if I moved up 1, that means y equals 1 plus, would you agree?
Yes.
Yeah? And if I were to go down and start down here, like this, then it would be minus. And then it would look like this. Do you see the difference?
Yes.
So now we are going to give these a name. A word we haven't used before. This one here, wherever it starts, whether it's here, here, or here, which is this one, is called the center line. Everything else remains exactly the same, doesn't it? So, if you see a graph like this, where this is 4, and we haven't changed the amplitudes with you guys ever. Yes. Let's say that this is 6, this is 5, and this is 4. what would the equation for that one be?
Y equals 5 plus sine x.
Very good. Now, that's easy to understand, right? Everybody's good with the center line?
Yeah.
Bye. So now let me change just one more thing, just a little bit. And I'm going to start at the center line 0 to prove a point. And then I'm going to move it. Sorry, did I spray you? So now I start at 0. But now I'm going to go all the way up to 10. And all the way down to 20. Sorry, minus 10. What changed?
The amplitude.
The amplitude changed. Where would I change it?
Y equals 10 sine of x.
Very good. Y equals 10 sine of x, because the sign remains the same, right? But I'm multiplying it times 10, which is why I go all the way up to 10 when I'm in 90, right? Because sine of 90, I suppose, is 1 times 10, 10. That's why I go all the way up, right? Does that make sense? So, what would happen if I combine the two? And I'm going to give you a completely different graph. And you tell me what the equation is.
Y equals
Y equals 5 plus 10 x 10 sine of x.
Does everybody see it?
Because it's 50 minus 5.
Because this is the amplitude. And we see that it goes 10 up and 10 down, right?
Yes.
Did I go 10 down?
Yes.
Yes.
Okay. And I start at the center line, which is this one. Okay? So we're good? Is that easy to understand? Bye. And, of course, you know how we love Saxon because he just jumps from one topic to another.
Yes.
This is one of those cases where you look at this. Now, couple of things. Capital A in arctan means you're just looking at the first quadrant of, so you're remaining here, okay? So, what's the tangent of 135?
Tangent of 45, so it's 1.
The first and the fourth. Uh-huh. So what do we do here?
Tangent of 45 because 90 plus 45 is 135.
You'd think that that would just give you 135, right? Because this one just gets rid of this one. No? This is tangent.
you take the tangent of,
You would just look at it and it would be 135.
so my answer is 35.
But no, that would not be correct if somebody ever reaches that conclusion. That is not correct. Question is why not?
Because math is
Because
weird.
The Saxon just wants
Saxon just loves.
Because if we look at the tangent of 135, let's see where it is. Because we have to do the parentheses first, which is what you said, right? Without speaking, I saw you do this. Is that what you meant? That parentheses go first? Exactly. You do 135 first, which is here, and you've got 45 over here. So what do you have? 1, 1, and square root of 2. The tangent of 135 would be negative 1. Because it is opposite over adjacent, which would be negative 1 over 1. So this is the arc tangent of negative 1. Would you agree?
Yes.
Why not? Where are you lost?
Why is it arc of negative 1?
Because arc tangent, I just copy arc tangent, and the tangent of 135 is negative 1. Do you agree? Now, where is the arc tangent negative 1? Arc tangent would be what? It's still opposite over adjacent, but
It's the other way.
now this would be, where is it negative 1? It's either here, right? Or here, right?
Now is the other one.
It's gotta be this one because it's a capital A. And it restricts you to the first and the fourth quadrant.
Yes.
Does that make sense? So now we know that it is negative 45 or 315. Does that make sense? So be careful, okay? That capital A restricts you a lot. Restricts you to the first and the fourth quadrant. We good? Yeah? So, in other words, to make it simple, always follow the rules of precedence. And PEMDAS is ever present. So parentheses first, when you do parentheses first, you see that this is -1, and that just brings you automatically to the fourth and first quadrant. Okay?